In this edition of Whiteboard Weather, we are going to get down to the truth. Does it really matter which hemisphere that you're in, which way the toilet water spins, or is that just fake news? Let's get into it in this edition of Whiteboard Weather. Okay, so believe it or not, there's a mathematical way to describe all this stuff, which is like with many. And I remember learning this in master's school, and I was like, this is interesting. I have to share it once, so before I forget it all, I'm going to share it with you. So there are a couple things that impact the way something spins. The first one is the speed that you throw it. So picture you throw something very light. It's more easily deflected, right? Versus something that is a beeline going very fast that isn't deflected as much. So the first variable we're going to check is speed, the thing that it's launched at, the start of it. Now in calculus is a fancy word, but in calculus we denote that by the letter U. It just helps me explain it better to you. The letter U, that's the variable that we use. The second is the Coriolis force. This is more of an Earth impact. So the further north you go in the northern hemisphere, the further south you go in the southern hemisphere, that has an impact to how fast things are deflected, like maybe potentially a toilet of water in the bowl. And then we use that by the curly letter F. The straight letter F was used for, I think, force or something like that. And the third is going to be the length or size of the object. In this case, we're going to use length, like a circle. We're going to use circles here. Length, and that's denoted by the letter L. And we could further group these two into separate categories. So speed, does speed have anything to do with the Earth, the size of Earth? Really nothing. No, it's me. It's what's generally happening absent Earth. So that's not impacted. Does Coriolis force have to do anything with Earth? Yeah, I think so, right? Based on where you are in the hemisphere, we decided it is. And length, believe it or not, before I get into an ultra lengthy explanation, it is also dependent on Earth, because when you get to further towards the equator versus further up north, there's less space. So that also has an impact. The length is all relative based on where you are positioned in the Earth. So we're going to group these together, and we're going to compare the value of these two. So we're going to look at speed, U, and the value over Coriolis force times the length, which is its own variable. Now, if U is greater than FL, the value of that means it doesn't matter Earth. We could be on anywhere. It doesn't matter that we're rotating. It doesn't really matter any of that. But if FL is greater, that means it is a factor. So we're going to use something that we know for a fact, right? We know that hurricanes spin in different hemispheres due to the fact that they're in different hemispheres, right? We know that they spin hurricanes. We know hurricanes spin counterclockwise in the northern hemisphere, and in the southern hemisphere they spin clockwise, which is weird to look at. I don't know, it's weird, but we know that's a fact. So we're going to test our theory. It's basically a theory. So in order to mathematically prove something, we're not going to use numbers like 2s and 3s. We're going to use round numbers. It's called scale analysis to get a picture about what we're dealing with, right? So a wind speed for hurricanes, and we have to use the metric system because that's the way this is all evolved from. Hurricanes are roughly on the deal of about 10 meters per second. 10 meters per second is about 20s miles per hour, so that's fair, right? Hurricanes, 20s miles per hour rather than hundreds, you're talking about 20s. That over the Coriolis force, which I would have to have another 10-minute explanation, but it's roughly 10 to the negative 4 in our latitudes here and 10 to the negative 5 in the tropics. So we use 10 to the negative 4, and the length or size of hurricanes, which ends up being, so picture a hurricane. It's not meters, it's not tens of meters, it's kilometers or maybe even tens of kilometers, and in my case, I think about hundreds of kilometers, which is about 60s of miles, does that make sense? So about 60 miles, which would end up being 10 to the 5th or 10 to the 6th. So we use 10 to the 5th for now. So this ends up being in meters. So let's take a look at it. You got 10 to the 1 over 10 to the 4 times 10 to the 5. Now, a throwback to middle school math, when multiplying exponents, you add them. So -4 plus 5 is 1, so 10 to the 1. And in meters per second is 10 to the 1 as well. In fact, it's really like 20s of meters per second. So it ends up being roughly about 1 to a little bit less than 1 for the value here. This means that hurricanes, again, hurricanes, it matters which hemisphere you're in. Now, let's think of something else besides toilets that may have different spin based on just meteorological phenomenon that we can explain. So the next one I want to use is tornadoes, right? Do tornadoes, it does depend which hemisphere the tornado is, does that have any impact? I'm curious, let's check that out. So we're going to use U over FL, wind speeds for a tornado. You can say hundreds of meters per second because you get very violent tornadoes, but it really is about the same as hurricanes. So we're going to use about tens of meters per second here. So we do the same. We're still going to use 10 to the -4 for a value there. And how big is a tornado? We're not talking as big as hurricanes. We're talking more so about hundreds of meters to about 1,000 meters. Now you can get mile-wide tornadoes, which would be about 1,000 kilometers, but it's really, I would say, hundreds of meters, like 10 to the 3, 10 to the 2. You're talking about hundreds of meters for a tornado. So let's do the math here. It's 10 to the 1 over, you add -4 plus 2 is 10 to the -2. And then you get 1 minus -2, which is 10 to the 3. So that's interesting. So we're talking about tornadoes is more dependent on the wind speed. The starting force of the wind speed is what direction it ends up blowing. So yeah, if you don't know, there have been many recorded times where tornadoes spin clockwise. And the main problem is, the main reason why we see a lot of tornadoes that spin counterclockwise is the systems that they form in. They usually form in areas that develop a counterclockwise flow, which is why we're used to tornadoes being counterclockwise. But tornadoes can very much spin both ways, and it doesn't matter which hemisphere you're in. Okay, now let's do the thing that you've been waiting for, the toilet bowl. Now, you may have already done this example before, so does it matter with a toilet bowl? Now, I'm going to have to go all the way down here on the chart, but I'm going to create a different line here. I'm going to create a different line here for the toilet bowl. So we'll start off with the speed of a toilet water rushing in. Have you ever thought about that? I don't think we're talking in tens of meters per second. I think we're talking about like a meter per second. Picture the water kind of going through. So we're talking about a meter per second, which is 10 to the 0. 10 to the 0 is 1. Now let's think about the Coriolis force, which is always, for the most part, 10 to the -4. And then what about the length of a toilet, the size of a toilet? It's not quite 10. It's not quite 1 meter, right? We're talking about a little bit smaller than that. We're talking more about decameters or centimeters. So we're talking about 10 to the -1 there. So we'll do the math. We're talking about 1 or 10 to the 0 over 10. You have to add these together, 10 to the -5. So we're 0 minus -5, which ends up being 10 to the 5th. So, like tornadoes, it does not matter. Whatever way that it's blowing or flowing when it first starts going, that's the way that it'll continue to spin unless it's acted upon in a different way. So hurricanes, we know they change direction based on the hemisphere. The toilets, no. It doesn't matter which hemisphere you're going to. So hopefully that was informative here. Hopefully you learned something new. If you have any more questions, hopefully not math this much in depth. If I went into why F was 10 to the -4, it would have been forever. But yeah, thank you so much for tuning into this edition of Whiteboard Weather. Hope you learned something. My name is Anthony Bordenaro here in the Storm Tracker 16 Weather Center. Have a good day.